Thanks for joining, everyone. My name is Braden McNeil. I'm the Technical Sales and Marketing Lead here at Aquanty. If anybody has any questions about the information presented in the webinar today or about HydroGeoSphere in general, I would be the person to reach out to. You can always get me by emailing sales@aquanty.com. We're here today to introduce HGSVTU, the powerful new post-processing utility for HydroGeoSphere model outputs. And while we say it's new, it's actually been included for almost 2 years or more at this point on installation with HydroGeoSphere. If you're on the call today, you're very likely familiar with HydroGeoSphere. This is, of course, Aquanty's flagship modeling product for fully integrated groundwater surface water simulations. Keshav, you can go to the next slide. Just very briefly, if anybody here has used HydroGeoSphere before, you'll know that it's a series of executables, including grok.exe, phgs.exe, and traditionally hsplot.exe. Grok.exe is, of course, a file, model preprocessor for HydroGeoSphere. phgs.exe is the actual numerical simulator. And when phgs.exe, it produces a wide range of binary output files. In order to reformat those binary output files for visualization in some visual post-processing or some visualization tool, whether that be TechPlot, ParaView, GIS, Earth Volumetric Studio, or any other kind of three-dimensional visualization program, we need to reformat those binary output files. Since the founding of Aquanty, really, and for over a decade now, the sort of de facto post-processing utility for HGS outputs has been hsplot.exe. But we've been at Aquanty quietly working on a replacement called HGSVTU.exe. It's actually been included on installation for, I believe, almost 2 years at this point, and has long ago reached feature parity with hsplot.exe, and in fact has introduced a wide range of additional utilities and features that are extremely helpful to HGS users. So moving forward, the software development team here at Aquanty will be deprecating hsplot. As of the December 2025 software release, which just went out today, when you run hsplot.exe, you'll see a message about how hsplot has been deprecated. This means that we'll no longer be providing any software updates to hsplot.exe, although it will continue to be included on installation for several months. However, because HGSVTU has feature parity and provides an additional suite of advanced features that hsplot doesn't offer, we're really encouraging everyone in the user community to start making the transition over to this new post-processing tool. So I'll leave the rest of the presentation to my colleague and today's speaker, Keshav Parameshwaran. Keshav completed his master's degree in civil engineering in 2022 at the University of Manitoba with a specialization in groundwater hydrology and soil sciences. His graduate research was actually focused on the physical-based hydrologic modeling to forecast soil moisture in a mesoscale catchment in cold climates. Prior to his studies in Manitoba, he actually received a bachelor's degree in agricultural and irrigation engineering at Anna University, India. Keshav joined our team here at Aquanty in 2022 and has been a very, very valuable member of our HydroGeoSphere modeling teams ever since. So I'll leave it to Keshav to do a deep dive on the key features and capabilities of HGSVTU. Take it away, Keshav.
Thank you, Braden. So hello, everyone. Thank you for the introduction. So the HydroGeoSphere, for anybody who has not worked with it before, runs with 3 main executables. I'm just reiterating what Braden was just mentioning right now. A data file, which does the pre-processing, called the grok, which can be opened in any text editor. And the purpose of it is it generates the input data files for HGS to read it. And after it is done, the main step of the PSGS is, or the HGS, is to run the problem whatever the user specifies to it. And when the HGS runs the simulation, it generates multiple data files as outputs. It can be binary other data files of any other format. And after that simulation is complete, of the PSGS step is done, in order for us to view the output data generated after PSGS, we use this executable called as the hsplot or the HGS to VTU, and they helps us to convert the output data to a format of any visualization and analysis. So right right now, as Braden mentioned, the hsplot is still active, but it will be deprecated very soon. And we have already started pushing any updates for the hsplot so that the users can adopt the newest and the most exciting update in the modeling software, which is the HGS2VTU. So HGS2VTU program can perform almost all the tasks of hsplot, but better. It can be used to convert the HGS binary output files and mesh files into various formats. The first is the vector tile unified grid, which is the VTU grid, which is the default, and it can be viewed in the free software called as the ParaView, where people can be familiar with this, and it can also generate other file formats like the network common data file, commonly called as the netcdf file format, which can be read by either HGS or any other programming language of Python or R of people's choice. We also, a lot of HGS users use TechPlot, especially at the university level. Also in the company level, people end up using the TechPlot licenses. And TechPlot, we can use HGS2VTU to create the SZL, which is the sizzle plot format, and which is also, it can read TechPlot ASCII files, and last but not the least, which is the easiest, CSV point cloud files, which can also be read in QGIS or any GIS or other user-friendly software. But just to note that I want to reiterate that the software shown here in this slide, all files can be handled in this softwares, but also if the user if they are comfortable working with any other software present in the market, they can use that to view the HGS2VTU file formats. So running HGS2VTU is very easy. All you have to do is open a console and type HGS2VTU, just like in the image shown on the right. The VTU file format is the default, and hence we can see all the binary files output converted to VTU file format, and which you can easily view in the ParaView software. You can execute HGS2VTU with minimal number of file elements, like the elements PM and the coordinates PM file, which is, and also the gen file, which you can see in your simulation folder when you execute PHGS or even CRUC. Just like how you see in the figure here, so you see the coordinates of channel, OLM, channel domain, OLF is the overland domain, and PM is the porous media domain, which you can see that in your simulation file folders. And additionally, just for this presentation purposes, I'll be explaining or keeping it short to only the overland porous media domains, while all the other domains like the channel, well, tiles, fractures are also included in HGS2VTU platform. All you need is the corresponding mesh files for that. So the start of how we do HGS2VTUs, it's pretty simple. All the command line options are grouped to a certain type of output, either time series or binary. It can be either grouped to a certain type of output, and most of all applies to a single group. However, few of them can be added with multiple options. We have three different options, which is the general options, where we have the basic commands like help, versions. The other people would prefer to use would be the binary output options and the time series output options, which can be used as mix and match and to create your desired outputs. I'll be giving in all the examples on how to execute pretty much all the commands which HGS2VTU has currently. First, I would start this chapter or slide. I will explain the basic commands of HGS2VTU. The help command, it's pretty basic. Every other program, be it GIS software or modeling software, has the help option, which does exactly the same as, like, if you are missing any inputs, if you are missing anything, it says what is available in that specific platform, and you'll be able to use it. And we also have the verbose outputs, which explains the type of outputs in a detailed manner, but it's an optional command. And we have a lot of other helpful minimal general options, which is like you use HGS to VTU dash version, which actually ends up showing you what version of the HGS VTU you currently use. And we have prefix command to see which the batch.pfx file, if people are familiar with the simulation, how to run PSGS, we'll be using that as the start, and we'll be this command will read that, and it is also another optional command which in case if also the unit systems, the revision numbers, they are all optional, such that there is highly unlikely that the gen file will not have it. In case if it doesn't, HGS to VTU, if you specify from it, you will be able to see what is happening inside those files. Note that in terms of the unit systems, you could specify any units of your choice, like kilogram meter per second, kilogram meter per day, kilogram meter per minute of all the sorts. We have 10 different options, which we can find in the user manual, which you can actually use. And but we have to note that the units which you are specifying in the HGS to VTU will override any unit which you specify in the grok file. The three main options which was specified at the end here, like the make, plot control, time series only, and the metadata file, they are all very important commands which needs more explanation, which I'll do in the subsequent slides. This plot control file, it's one of your best friend when you try to execute or explore different variable outputs in different model domains. It works hand in hand with HGS to VTU and also hsplot. So when you execute the command line as shown in the figure at the top here, HGS to VTU make plot control, it ends up creating a prefix.plot.control file, which has by default all the domains like the porous media, channel, OLF, others all returned to an output. So this, as an example, figure on the right shows how the basic plot control file looks like. The right PM domain file, it starts, I'm just explaining, this is a whole big file. I'm just separating it to different domains so that it's easier to follow here. So it starts with right PM domain file. It will have an end option, and all the variables which is present in the porous media domain will be stopped with an exclamation mark, so that if you end up removing it, it will say, oh, it will not write that PM domain certain variable which you're asking it to. So you can control which variable and domains you would like to get as an output for either commenting out the whole domain or an individual variable in a domain. So example, adding exclamation mark, like commenting out the on top of the right PM domain, and its subsequent end statement at the end makes the entire PM model domain to be skipped. So something similar. So this is an example for the dual, OLF, and the fracture domains. And it also finally has the well, tile, and the channel domain. It pretty much, this plot control file pretty much has all the domains and all the variables which currently HGS has. And last, it has the time series output as well. So if you're in this, time series output will be at the end. If you're removing any exclamation mark on the certain variable which you don't want to write it as an output, you can also try controlling which time series output, especially like important files like soil balance and water balance file. If you just want to use it, we can just only get that output files. We need not necessarily take all the variables of all the domains. So also, a point to note is that the variables and the domain can change in the previous and the future versions of HGS to VTU. So if we end up deprecating any old commands, we won't be using it. And if we are adding new commands, that will be added in the new plot control versions from newer versions of HGS. So the first binary output after the general options is the most easiest, which people who would try to use the most easiest command is the CSV format here. the command is the easiest form. It's very simple, and all you need to do is HGSVTU --CSV. It's the easiest form of data to visualize, and they are generated for each of this binary files for the domains which you have specified in the plot control file. Here in this example, I am turning on only the overland flow, OLF, which is the overland flow, and the PM, which is the porous media domain. And we can get both the cell-centered and the nodal values output. So HGS, as people know, works with elements and nodes. So variables such as the head, the saturation, the volumetric water content are nodal variables, while friction, hydraulic conductivity are all elemental. So depending on which variable you want to convert your CSV file into a raster, you can use them, import them into into GIS software, and you can take out any variables you want. The CSV file opens to this way, so I'm just giving it as giving an example of how an olf.nodal file opens as. So it has pretty much all the columns of XYZ coordinates, and every other column will have its own variable inside it. hsplot cannot do this. There is no point of using or getting a CSV file with hsplot, but HGSVTU can create the binary file output, like a CSV file for each binary output times you have. Here, I am giving an example with just 3 output times. So you have 1, 0, 0, 1, 0, 2, and 0, 3, just 3 binary outputs, which you can open and use see the CSV file how it looks. So, and you can end up importing the CSV files into any GIS software of your choice and convert it to a raster. So thin interpolation is usually preferred, and you can choose any variable in this. Like you can use elevation to create your recreate your DEM, head channel, or any log depth, anything of variable which is currently present in HGS right now. So I can give an example on how to import this HGS to VTU processing output which has been created. This is an example of a model domain after I import the nodal CSV file. Just like I was mentioning the previous slide that we have both cell-centered and nodal, I am importing here all the nodes which is present in one of the output times, which is while I was executing a simulation. The variable I select here would be the elevation. So I want to recreate an elevation raster. The enlarged version here shows the packed nodes distributed equally according to how you generate the mesh. And the subsequent image here shows all the elevation values present in each of these nodes. Here, when you import this inside the GIS software, I'm using QGIS. I'm pretty comfortable with it, and you can see when you import this, you will be able to see all the variables inside each of this interpolation attribute. I am suggesting thin interpolation because if nodes are spaced equally, it is better we use interpolation. If not, you could also try kriging if you like. So when you import the CSV for interpolation, as you see all the other variables, you can literally export any other variable of any domain of your choice if you end up getting the CSV output from this time. So this will give me an exact, if I want to look at spatially varied results of any of the flux present in that exact time, I'll be able to convert that into a specific raster. So it is pretty simple. So when I was explaining the general options, one command was the netcdf file outputs, which reads as a human readable configuration file called as the YAML file, which is pretty much necessary or it is mandatory to have to create netcdf file outputs. So generating netcdf files, it's pretty easy to, just like I was showing in the previous slide, how you create a CSV file. The command would be again HGS2VTU --netcdf, but here we just add the general option of calling in that YAML file, which is --meta file and beer.yaml. Beer is just nothing but the prefix of your model. So once you execute it, the netcdf files for all the binary outputs will be generated, just like how you can see on this image. Few And there are a few common errors which people end up making while creating their own YAML files. They while creating an attribute, they end up not creating those brackets. And when it comes to the CRS codes, which is pretty important, while running that CRS code, which is required to set the spatial coordinates, we need to adhere to the right EPSG formatting, which is accepted by Proj. Just writing EPSG and a number like 26914, let's say, for example, which is in Manitoba, it does not work that way. We have to follow the exact Proj syntax, which you can find online. It's pretty easy. And the epoch date, the start date, as you mentioned in the simulation, and the epoch date, it's an optional command, but it defaults to 1970 January 1st if you do not mention it. If any of this information is difficult to fill, if people are not familiar with filling up the YAML file from their end, still no worries. HGS2VTU will end up giving a default file, which kind of looks like what you see in the image right now. So this is how we start creating the meta file to create netcdf files. I can show a smaller, just like how I was giving a small example of how you import a CSV file after you create a HGS2VTU output. So again, I am creating a netcdf file from HGS2VTU as an output, and I'm trying to import that inside, or how do you view the netcdf files like this. So this is a small video where you could use any online tool to merge all your netcdf files of binary outputs into one, and all you have to do is I don't recommend drag and drop of these files. So we use add mesh layer from that layer, browse to the path where you have your netcdf file and add it to your layout. Usually all the netcdf files are inherently WGS84 projections, so you would want to reproject it to the correct coordinates in this case it's UTM-18N. So you can then explore the properties just like how you would work with the normal polygon or the raster in any of your GIS, just like how just one merged netcdf will contain pretty much all the variables of a specific domain. For this example, I'll just choose the surface water depth in the OLF domain, and you can turn on the temporal control panel in pretty much inside QGIS export, and you'll be able to see how the time varying here. So in this one, I have the animation range or the time frame from 2008 to 2017 and the time increments which starts in dates. And when you start it, you'll be able to see how the surface depth varies in daily time intervals. It's pretty much exciting to see, and the resolution does not disappear even when you zoom inside it, and it's I would say it's pretty slick. And you can also see the mesh if you like, and you can turn on play with transparency, the opaqueness, and that's pretty much it. Anything which you can view in ParaView or the tech plot, you'll be able to see in QGIS if you end up importing the time changing netcdf files. So again, it's pretty convenient to see how netcdf when you export it from HGS2VTU. So a lot of people even now end up requiring the tick plot, SZ plot, or the sizzle plot, and the ASCII plot formats. A lot of people are very familiar with how you use that in tick plot instead of ParaView. We generally prefer the sizzle plot format options when compared to the tick plot ASCII, as you can see from the image on the right. When you use the tick plot sizzle plot options, the OLF domain is like 2 GB, and the porous media is like 22 GB. It takes a lot of computational time to generate all the output times and also open it. And if it in the worst case, like tick plot ASCII file, you could see one file of the porous media with lot of layers, nodes. It is like 80 GB of data. So it takes a lot of power. It's even difficult for a conventional machine of i9 or i7 configuration to open this file like fast. So we tend to use the sizzle plot format, which opens quite quickly. So when writing the tecplot binary output data, the data is usually cached in memory and only returned to file when the file is either closed or flushed out. And it's recommended for periodic flushing, where working with, when I think a lot of people work with really huge scale models, so it helps in avoid exhausting all the available memories. But when you end up creating a larger flush interval, you would result in a better performance, but it will also cost you high memory usage. The reason why tecplot kind of does this is tecplot ASCII files has its own way of converting the binary outputs to a tecplot readable version in the backend. So that is why the file takes a lot of time to open in your computers. So we also handle a lot of 2D model domain with the shapefile option. If people just wants to only view results of a certain area in their whole domain, that is possible too. So the figure on the left here shows the whole model domain of Beerbrook in Ontario and a small sub-basin present on the west end of the model. You can all do this to your own models, but I'm just giving this as an example. This would take into view, I would just like to view the results of that sub-basin only, just present on the west end here. Here we can use the command, the clip shape, which all you need as an input is the shape file of a certain sub-basin or in any polygon of if you want to see any area of your choice. We can use that command, specify the name of the shapefile, and that shapefile should be present exactly in your simulation folder. And as a default, if you end up only using this command, HGSVTU, clip shape, and the shapefile, you will end up getting the VTU files as an output of that specific clipped shapefile. And again, you can import that into ParaView and you can view the results of it. And if you extend that command to say, I want to view that in tecplot in a sizzle plot format, you can import that output which you get from it inside tecplot, and you end up visualizing the same results. This does not end here. There is still continuation of this commands, which is also pretty easy. The first would be, let's say you have a polygon shapefile with the default WGS84 and in any other projections, or not necessarily WGS84, it can be any projection. What we can do from HGS to VTU is that you can say shape project to a source and a target CRS, and you don't like you can do the reprojection in HGSVTU itself instead of going to a GIS software. And the next thing is you can even continue doing it after reprojection. If you want to say, I want to look at only a certain time range of intervals, so we can say I want to see the simulation time range from a certain start time till an end time. Here, the time here which shows is only in seconds, because inherently the simulation uses time in seconds because the units was in kilogram meter second. And you can see an output data which reads from 5 e power 8 to 6 e power 8 seconds, which inherently uses only seconds. But you say if people are not comfortable with using seconds as their time, they can use this UTC time range option. Just for this example, I'm using a simulation time range of 2016 January till 31st December 2017. If you execute this command, it will end up showing or asking you an error saying that, oh, there is something missing here, which is the UTC time range or the epoch date, which needs to be written in that YAML file, which I was mentioning at the start. So all we need is a small extension of this command after you give the UTC time range, a start date and an end date with them. And all you have to do is you call in that YAML file, which you have created at the start, and it will also end up producing you the exact same result. So 2016 to 2017 December is the same time sequence of what I was just explaining. So it'll end up giving the same output times. So it's pretty easy on how you could do clip, do the simulation time range, and convert it to your own file formats. So the last of the three options is the time series output options. The viewing output output files as the time series outputs is done after processing the binary output files. So if you just want to view the time series output options, you could just comment out all the domains like the channel, the overland, the porous media domain in the plot control file and get only the time series outputs. So in case if you don't want to get all the binary files, you just want to see the time series files, we could just uncomment only write time series files in the in the plot control file, and we can view those results. Just for this presentation purposes, I'm only taking into account this few files, such as I want to see hydrograph files, Newton runtime info, the observation wells, soil and water balance files. These are important files. Well, the Newton runtime info, it's a pretty useful file which contains all the numerical errors, time stepping, all the other things. Well, all I'm saying is it is an important file as well. I don't want to diverge too much. Okay, then again, in the command prompt, as you can see, the command would be pretty simple too. HGSVTU -- time series.csv. If I want to look at all the time series files of the variables which I just mentioned, we can look at or export it as CSV and time series. So when you execute that command, we can look at the output, which shows all the hydrographs, the Newton info file, the soil balance, and the water balance files being converted to individual CSV files. Each hydrograph .dat files are being converted to individual CSV files like this. And your simulation folder should kind of looks something like this, where you see all the individual CSV files which are converted from .dat files to CSV. It will not delete the .dat files. It will still keep the old default files as is, and it will end up converting the CSV files. And in this example, I'm just showing, I'm opening a hydrograph file, and your hydrograph files CSV kind of looks like this, with the header at the top and all the surface. But you also get the variables of each of the hydrographs should be present in. And the time here is in time stepping of in seconds, which is again inherent into the model. Because this has time in seconds, people end up doing resampling to either hourly, weekly, monthly, or yearly, anything of their choice. So this is one example of how we could convert time series to CSV here. And the next one would be, in the previous slide, we were looking at only the CSV outputs, but here I'll be explaining about converting the HGS text.ascii files into netcdf time series files. As I have mentioned at the start, that when getting a netcdf output, we again require a YAML file. So unlike CSV, all the CSV files are again converted into only one prefix time series.nc file here. So all the command just says, instead of typing time series CSV, all we need to call is time series netcdf. But again, we have to call in that YAML file as well. So it's like, rule of thumb is, if you are creating netcdf files, please call in the YAML file along with it. Then this creates all the hydrograph, all the soil, water, all the variables which I mentioned are asking to be exported as an output, gets created into only one time series .nc. But if you say, I want to see almost all the outputs as an individual files, we just have to create or add a small command called as --multi-file, which will create individual netcdf files for each of the variables which you just wanted. So if I want one hydrograph of one dat file to be exported as individual netcdf files, you could do that by adding in that multi-file option. So by default, the water balance is always converted to an HCDF file first. I mean, if you want to look at the water balance file, if not, then you could comment out that too. So by default, the NetCDF files has a fixed time dimension in it. So using unlimited time command likely results in faster conversion times of the time series of NetCDF files, but it also costs higher memory usage. But we can and we can also compress the NetCDF files like by we can do chunking on it. So we chunk the time dimension with specified chunking sizes, and also use the deflate levels to do that. It's also pretty convenient tools. So the last item on today's agenda is the resampling of the NetCDF files. So currently we can only resample the NetCDF files. We're also thinking of doing that for CSVs, but currently we can definitely do it for the NetCDF files. So a few slides ago, I was mentioning that it would be difficult to follow the time in seconds with irregular time stepping. So you could resample it to daily, hourly, monthly, or yearly as per your convenience. So just like in the extension of previous command where you're just asking the time series netcdf and calling in the meta file or the YAML file, we have to just extend it by saying we are giving it a resample range. We are giving it a resample range by saying which rule it should follow. So the rule can be 1 day, 1 hour, 1 minute, or any number of seconds. Then you have to give a start date and the end date to which it can resample to. So here as an example, I'm only creating a multi-file approach for soil balance and the water balance output. It actually comes as a .nc file, and in here, if when it goes to time series, as I was showing in that video of how a time series works of daily in that video, it be there is no way in HGS to VTU as of now to merge all the netcdf files of the time series into one as of now. So you could do any post-processing, very simple post-processing to combine or merge all those netcdf files into one, then end up printing what the results kind of look like here. As the command says, I want to resample this simulation time interval for 1 day time interval from 1997 till 2017. I was able to see that the resample happened from 1997 1st January. Then it goes on to increment from daily time intervals like 2, 3, 4, and it goes all the way till 2017 end of December. So this is how easy the resampling of netcdf is. And again, this doesn't stop here. We can also do multiple other commands. So let's say if you want, in the previous slide, we were doing daily time interval resampling, but here we could do the resample period of yearly. So all I'm saying, again, giving it a year start where say YS, which will be the year start, and I'm giving it a start time, which is just say for this example, it's 1997 1st January, and the number of period to which it has to give the outputs for. So in this case, it will resample from the year start of the simulation to only 5 number of periods. So here in this case, we will see 1997 1st January till 2001 1st January because it is 5, because I'm asking it to only give 5 outputs from 1997. And it will be 1st January because it is the start of the year. Next one is, again, if you want to see what the end of the year looks like, all you have to do is change in command, which will be the YE. And in this case, I'm just saying it will be to the 1st January 2000. I'm giving a start time to it, and the period is just 4 numbers, and it would give me the end period of each of these years. So the start, since I'm saying it as 2000, you could see the end year data of or the dates of 2000 31st December, 2001 31st December, and I'm asking it to only give me 4 outputs, so it will be 2000 to 2003 end of year values. And again, this is for yearly, and we could also do this for monthly if you want. Again, the resample period should be the month start. If I give the example of 2000, again, the result should be pretty straightforward. I want the 4 months of 4 monthly outputs of starting from 1st January 2000. So it should be 2001st January, first February, then March, then April, because I'm asking it to only give me 4 outputs. So I wanted to give something crazy in as well to see if the HGSVTU was able to handle different times in it. So yes, for this resample range, I'm giving it as 5 days, 10 hours, 15 minutes. Nobody really wants to see like if the pretty default is everybody wants to see daily, monthly, or weekly, or yearly. I just wanted to see, but HGS to VTU is capable of doing anything as crazy time intervals as well. So 5 days, 10 hours, and 15 minutes, I give it a start time from 1997 to 2017. It will end up giving me all the proper results. It starts from 97 time 0, and the next would be like 5 days, 10 hours, and 15 minutes, and it will go on till the end of 2017, giving me what desired outputs which I want to give it for. So these are the basic examples of resampling. We could do a lot of trial and errors with the same type of resampling, but again, this only happens with the netcdf files. So other commands which people can end up using is the interpolate depth to groundwater. So depth to groundwater, currently it uses linear interpolation when computing depth to groundwater. If you don't use that command, it is mostly nodal. We also have groundwater recharge, which computes the groundwater recharge from the overland domain and as well as the channel domain. We have clip layer, lower and upper, which is the subsurface. We can also create, just like I was explaining about the 2D model domain, we could also use different, if we want to clip different layers, like if a model has 15 layers, if we want to look at the results of maybe layer 3 to 5, you can clip it using HGSVTU. And we also have the cumulative water balance file as well. So the cumulative water balance, for all you have to give is the the start of the time frame, from which your simulation start time to end time. It will end up creating reading the water balance of your simulation and end up giving you a cumulative average inside a CSV output. And also, if you want to view that in TechPlot, you can also do that as well. So currently, the point to note here is we currently have limitations in the netcdf output. We only have a certain number of variables which can be used to see the netcdf output. We can share the list with anybody if people are interested. If people are not comfortable using Python or QGIS to read the netcdf files, there are like few online viewer options. I think that this Panoply, it's NASA's own. They use this to see the results for the to view the netcdf files. It's free. You can find it online, and there is also NCView, which it's also pretty convenient to just view the netcdf files. So the near future upgrades of what HGS2 VTU, small typo there, has is that we have stricter command line controls. But as I was explaining all the commands in the previous slides, you can mix and match different commands. Right now, it will still end up giving you an output, but in the future, we are going to make it much more stricter to make the process more streamlined. And also, since as you could see, the command line getting longer and longer, all the commands can be added in a TOML config file, which reduces the hassle to write this really long commands every time when you complete the simulation. So just similarly how we could execute the CSV files, we could also in the near future, we'll be able to get shapefile outputs as well. So the vector data can be easily converted to your raster formats and can be used with it. And we also have faster writing times for the ASCII output files. So these are all the near future upgrades to HGS2VTU, which the users can look forward to. And I would like to credit few people who helped me to understand few concepts here. Dr. Killian Miller, he has been instrumental in developing this HGS2VTU, and Graham, Eric, and Braden, they have been helping me to learn few of this HGSVT commands. So it's almost time to say, or just call it quits with hsplot executable, and pretty much embrace the new concepts of HGS2VTU. And yeah, learning new is always fun to stay on top of things. So that's about it for me.
Okay, thanks again, Keshav. Once again, a reminder, if you have any questions at all, feel free to reach out to Keshav or the team at Aquanty. Email sales@aquanty.com or support@aquanty.com. We'll make sure to get you connected with the right people. Thanks everyone for attending, and have a great day.